Hey everyone, it's Mr. Payne, and I just wanted to now go over slide number 4 for us. So, if we look at our study guide on slide number 4, we have a question kicking it off talking about the density of certain metals. So, we have a question that says if the density of magnesium is 1.4 grams per centimeter cubed, and that basically just means 1.4 grams of stuff within a certain volume. So that means we have a certain volume, which is a cubic centimeter, right? We have that area and how much stuff is crammed inside of there, right? So think about like the difference between a really dense, heavy cake and a not so dense, like a really light, fluffy cake, right? It's the same amount of cake, but it just depends on how much it's jammed or how small it's jammed into. So let's talk about this. Magnesium, right? Magnesium has a density of 1.74 grams per cubic centimeter. Magnesium, we look over here, is in fact, excuse me, at the top here. And then the density of strontium is 2.63 grams per centimeter cubed, which is down here. And we're trying to find this middle point right here. So I showed you a way to do it in our note video, but now I'm going to show you an even easier way to do it. We have to find the average, right? I told you we have to find the midpoint. Well, finding the average is pretty easy, actually. We just have to add up 1.74. So let's go to our calculator. So we take 1.74, and we're going to go ahead and add that to 2.63, right? Our other value, 2.63. So you add the two numbers up, okay? I already forgot. I think it's 2.63, right? We add the numbers up. We get 4.37. Now that's not our answer because we're not at our midpoint yet, right? So we added up these two values, and to get to our midpoint, it's the same as last time. We divide it by 2. So if we divide by 2, we end up getting 2.185, and that is our answer. 2.185. 2.185 grams per centimeter cubed, right? And done. You're done with that. So you just add up the two values, then divide them by 2. You find the average. What is the trend for density as you go down the column? Well, let's actually look at our answers and discover that. So, magnesium up here is 1.74. Calcium right here is 2.185. And then strontium is 2.63. So, as we go down the column, right, as we go down the column, we see density increases. Density increases as we go down. What would you expect the density of barium to be, greater or less than strontium? So compared to strontium, well, we already know, right? We said density increases as we go down. So if barium is below strontium, we would expect it to increase. And if we were to explain, we would say because it's lower than strontium. And that's how our trend goes. I'm not going to type that out. You guys know that. Now let's look at our periodic table here. I'm just going to zoom it up a little bit so we can look at it. So elements in the same blank have similar properties. Now, this is just like the example I gave about you guys, right? You have a family, and your family and you have very similar properties to each other, whether you like to admit it or not, right? So, elements in the same family or group, because you could say the same thing about your close friends, your friend groups, right? You guys have similar properties, similar characteristics. You behave the same. So, families and groups are going to have the same properties. Where are metals located? Nonmetals and metalloids. Well, we should know this, right? Red, that's going to be our metals. Yellow, that's going to be our stairs or our metalloids. And then finally, we have our nonmetals, which is where oxygen's going to be, nitrogen, things we know are gases, right? Blue, helium, nonmetals. See that very well. Odd. Nonmetals. Okay, so list 3 properties of nonmetals. Well, nonmetals, we knew from our lab that nonmetals are brittle, no shine or luster, and then non-conductive, which means electricity won't pass through them or heat doesn't pass through them very easily. All right, so that is slide. Oops, excuse me. That is slide number 4 for you guys. I'm not going to do this slide. I am not going to go through slide 5. You guys know how to write CERs. I feel like I don't need to cover that. But I will release one more video of me kind of going through what valence electrons are probably. Or I kind of hit on that in this video. So maybe I'll hit on it in this and then we'll be done with it. So remember, valence electrons, we count up as we go through the periodic table, right? This first column has one valence electron all the way through. This second column, these atoms, they all have one valence or two valence electrons. Then we have 3, 4, 5, 6, 7, 8, right? And valence electrons, remember, these are just electrons on the outer shell, like I showed you here in carbon, right? Carbon has 1, 2, 3, 4 blue electrons sitting on this outer shell. If we go look at our chart, we see we have 4 right above carbon, which is true. So how many valence electrons does oxygen have, right? We have 6. We can see that from our table. And then finally, iodine. How many does iodine have? Well, iodine's right here. We look up here at 7. We know it has 7. All right? That's all we have to do for that. So that's your entire study guide summed up into about 4 videos. Again, you guys are going to crush it. I know it. You can use your digital notebook and your study guide for this test. I'm completely fine with that. If you have no questions or don't want to message me on Schoology, I will see you guys in class. I look forward to seeing you. We're going to have a good time. So thank you.